Hi students, this is Mrs. Foy, and this is a screencast about how to build an atom, the subatomic particles that are in an atom, and what atomic mass, atomic number, isotope, and ion means, okay? So you will recognize this as the PhET simulation that we did in class, and it's on Edmodo, and I highly recommend that you play around with it a little bit because it really does help you understand a lot of what we're doing. So the most important thing about an atom is the number of protons. So, and protons are found in the nucleus. This model is not accurate. Remember that if you blew up the nucleus of an atom to the size of like a basketball, the electrons would not be found until a half a mile away. So remember, an atom is mostly empty space. But this is a model that helps us to understand where these particles are. So protons weigh 1 AMU, and neutrons weigh 1 AMU. So the most important thing that we find about protons is that when we add protons, that is the atomic number. The atomic number is in the lower left of the nuclear symbol here. So the atomic number for hydrogen is 1, the atomic number for helium is 2, the atomic number for lithium is 3. And if you change the number of protons, there's beryllium 4, you change the atom, okay? So you're noticing that it says that my nucleus is unstable, and that's because the other subatomic particle that's found in the nucleus is called a neutron. Now, a neutron does not have a charge. A proton has a charge of +1, so you can see that I have 4 positive charges here, and so my charge right now is a +4. This is a positive ion. An ion is a particle that has a charge. So in order to make this nucleus stable, I need to add some neutrons. So a neutron weighs 1 AMU. Notice when I'm adding neutrons that I am also increasing the mass number. And the mass number is the number up here in the upper left, that is the number of protons plus neutrons is the mass number. It's a whole number. So I just added 5 neutrons to my 4 protons, and I just made the beryllium nucleus stable. Notice that my mass number up here is the number of protons plus neutrons, same thing as here, and my atomic number is the number down in the lower left, which is the number of protons. Now right now I don't have a neutral atom. Atoms must be neutral. So I need to add some negative charges to make sure that that is neutral. So I'm going to add my electrons. Notice that my net charge is decreasing more toward neutral as I add negative charges. And this model, this simulation is also showing you where these electrons go and these certain things called energy levels. Notice that my mass number has not changed because electrons basically don't weigh anything. Oops, I added one too many, didn't I? So now I have way too many, there we go. There's my neutral atom. So I added 4 electrons, here's 4 electrons, which cancel the charge of the 4 positive protons. So that is an atom of beryllium. But if I were to take away an electron, I have now made a positively charged ion, okay? Because I have 1 more proton than I do electron here. And if I take away another electron, I have a +2 charge here, all right? If I wanted a negative charge, I would have to add more electrons than protons. And we know from the very beginning of class in the fall that everybody in beryllium's column is a +2 when they form an ion. And so this would be what beryllium looked like, okay? So, let's make fluorine. So I need to add some more. If I look at the atomic number for fluorine on my periodic table, I see that fluorine has the atomic number of 9. So I'm going to add some more, and notice that I made boron, carbon. Here's my atomic number here. 7 nitrogen, oxygen, and here's fluorine, okay? Now fluorine is 9 protons, but my nucleus is unstable, so I need to add some more neutrons to make my nucleus stable. And what I am doing now is I am making different isotopes of fluorine. So an isotope is going to be an atom that has the same number of protons but different number of neutrons. So this is an isotope of fluorine that weighs 17 AMUs. Here is an isotope of fluorine that weighs 18 AMUs. Here is an isotope of fluorine that weighs 19 AMUs, and that particular isotope is stable. The other isotopes are isotopes that would be like radioactive because they're unstable. So here is my fluorine atom. Now, it's not an atom yet because I don't have a same number of negative charges as I do positive charges. Remember, atoms are neutral. So I need to add 5 more electrons. Okay, so now I have a neutral atom. I have 9 protons and 9 electrons. So my net charge is 0. But fluorine, when fluorine becomes an ion, as all of these atoms over here in this column, they like to be a -1 charge. So to be a -1 charge, I would need to add an extra electron to make the fluoride ion, which is -1. All right? So let's take a look at the worksheet that you did for homework for yesterday, and let's take a look at some of these things. Here's my pen. Here it is. Okay. So, so let's take a look at the very first problem that we did here. Whoops. Wait a minute. Sometimes late in the day, my computer gets tired. Okay, here we go. Okay, so here we go. The number of protons, 53. So if I look at my periodic table, I see the element that is 53 is iodine. Okay, iodine. Now, I have 53 protons. That means it must be iodine. But look, I have 54 electrons. So that means I have one more electron than I do protons, and that means this guy is going to be a negative charged. It has gained 1 electron. You can't gain or lose protons, guys, because that's going to be a different atom. All right, so here's potassium. Potassium's number of protons is 19. I looked at the periodic table and I found the atomic number. So over here it says I lost an electron. So that means I'm only going to have 18 electrons. Well, those are positive and those are negative. Does everybody see that I'm going to have a +1 charge? Okay? So those are ions. You positive and negatively charged ions, okay? So now let's take a look at the isotope page. Isotope, remember, are atoms that have different numbers of neutrons. Okay, so here is the shortcut way of writing an isotope symbol. That number right there is the mass number. And the mass number is the number of protons plus neutrons. Okay, so if I look at chromium on the periodic table, it has 24 protons. All chromium has 24 protons. But this is going to have a different number of neutrons. So this, I'm taking 58 minus 24, that is 34 neutrons, okay? And then this isotope of chromium is going to have 63 minus 24 neutrons, which is going to be 39 neutrons. So chromium 63 is a heavier isotope than chromium 58. Now, it's not an ion, it's not charged, and so the number of electrons is going to equal the number of protons because there's no charge here. So when I look at the atomic mass, the actual weight of the ion of chromium, it is 51.4 99961 AMUs, okay, for one atom. So the atomic mass is going to be the average mass of all the isotopes of chromium. So I can see that chromium 63 is a heavier one. Chromium 58 is also a heavier one. So obviously there must be some lighter isotopes of chromium because the average mass of chromium is about 52, okay, or 51.996 rounded down. So obviously these isotopes of chromium must not be very common, or my atomic mass of chromium would be a lot heavier. So hopefully that has been helpful for you, and make sure you play with that simulation. That will really help, and I will see you in class.